stick tensor and ball tensor. So we can take the effect of all the points, neighbor points, that if it has ball tensor, what is the impact of this one? It has ball, what is the impact of this one? It has a ball, what is the impact of this one? We can take a summation or integration. Similarly, it has some stick tensor component, it has a stick tensor component, it has a stick tensor component, everybody has a stick tensor component. We can take the impact on the center point. So at the center we can get the resultant stick tensor, resultant ball tensor. In this manner, the impact we can calculate, and this tensor, which is initially taken as 0 or the minimum one, it grows. So after tensor voting, my tensor at each point get refined. Again tensor voting, it becomes dense. When every point tensor becomes dense, then we can check whether it's a surface, curve or a point. This is what I'm going to explain in these topics.
We find the third column is just the angle. If you look at the code, the third column should be just the angle.
Angle for
approximate for at that location. For example, you think of the image, then
and
the image can have a line there anyway. So that's basically just an angle.
With respect to
just from 0 to 360 degrees. So it can be like vertical or something like that.
so it's just following the orientation of
the orientation of that point. So
yeah.
then if you have the banana, that will be.
Are you done?
But how would you calculate the answer
Yeah,
apart
that's
from
the
the
thing.
previous
Like,
lecture?
Okay.
I think one possible way is after you get the point, if you have an edge detector or something like that. If you have an edge detector for the image, then you can just get
No,
the
but
edge.
we're talking about 1 pixel.
Yeah.
Yeah,
One
so
pixel. But that pixel on the edge. So for example, if you have a pixel here, the pixel then the angle will be like. So like let's say this is the edge. So then the edge will be like.
in that case, the angle can be positive or negative too. But
Yeah.
no negative.
From 0 to
360.
360.
360.
360.
Okay.
How about for a single point over there?
That I don't know how they, because that's the what we do it for 40 minutes and despite it for 3 weeks, so we don't know like how we can answer that question now. But so yeah, I don't know how they generate the data from the beginning, but you can let's say what I imagine is that if you have an image, what you can start with is just do some edge detection. Then if you get edge detection, then you just pick the points in the edge. Then you can do a gradient for that. So you have initial something like that. So initial is like this. So you have some noise there also, like this is not the edge, right? So you have something like that. So then you want to get the shape. So you only have lots of point here, and you have some garbage here. And doing the voting eventually will get you like
Get back to
the
you
rest.
there.
And then you can discard the rest.
Yeah.
But so why do we need tensor?
Actually, for
for the tensor, it's basically okay. Here is basically the tensor is give you not just the location but also like the.
So it's just a representation.
Okay, it's just a representation here. It looks like at least for 2D it looks like that. So 3 dimensions would be more tricky. I guess like you have a surface there. So, but 2D it looks like it's just it's kind of simple.
No, but in 3D, right? Is it
3D I don't know.
No,
I
is it-
cannot imagine now.
like is it like a triad? I mean, with rank 3,
the rules should be
can we do a surface
So would it-
reconstruction?
include the
Yes.
gradient or something?
I think so.
Actually,
Tensor voting.
that's why it attracts me. Is like I went to a plenary.
This
like,
is
in
the
a
way to
conference.
find the surface.
It did really well. I mean, they just got a bunch of garbage, right, and then they formed the surface of the volume. So now I think I understand 2D, but I don't know how 3D they. Angle, for example, like you can use edge detector. So you, how do you do edge detector? For example, you can just do a filter that, now I forgot what the filter like. You can,
like the high pass filter to get the edges.
for example, you can have, okay, let's say I invent one, a very silly one. I can do like 1, 1, 1, like this, minus 1, minus 1, minus 1, that kind of filter. Then what it does, it will, if you have something that is line, let's say if I have an edge here, so this is dark and this is bright here, then it will kind of, if you put this to that, you will have something positive, right? What I mean is that if you
Do you mean do a convolution to the
yes.
image?
That means that let's say
1D
your
max.
pixel is like, let's say if 20, and this is like 0, 0, something like that. Let's say I do a filter like 1, 1, minus 1, minus 1, minus 1. And I can have another filter 1, 1, minus 1, minus 1. Something like that. If I apply this one to here, then I will get 0. When I say apply, I mean I multiply this guy by this guy, by this guy, this guy, by this guy, this guy, this guy, and they sum together.
Yeah.
So in that case, this will give me 0.
Yeah.
And for this side, it will give me like
Negative.
something positive,
Yeah.
negative. And then, so basically, we will detect like edges have this kind of horizontal edges. And this one will detect vertical edges. So after you do that, and then you just, of course, you can make different kind of filters and
Subtle, improve.
yes, different angle. But this is just a very like simple way to do that. Then, for example, like the most naive way that I just mentioned, you can have a bunch. Of course, you won't do that. You have a bunch of